Math isn't difficult. Math is fun. I am Neelakanta Bhanu Prakash and I am the fastest human calculator in the world. And we are exploring infinities. Exploring infinities is here in front of you to give you a mathematics learning experience like never before. With expert trainers from around the country, we are here to make you learn math the right way.
Hi, I'm Anshika from Exploring Infinities and welcome back. This is the second lecture for the chapter Quadratic Equations. So till now I have introduced the chapter Quadratic Equation to you. What exactly is quadratic equation? So whatever your quadratic polynomial is, you just equate that to 0. So you get your quadratic equation. It's very important for you to understand that you have a quadratic polynomial on one side and that when equated to 0 is a quadratic equation, because today we are going to use that concept to probably form another concept. Okay, so in last class we saw that we solved a few word problems. So in the word problems the question was we had to find the length and breadth of that particular plot maybe, or we had to find the Rohan's age. So I told you that we can form the quadratic equation. So we understood how do we form the quadratic equation. So beyond that we don't know. So we'll today see how exactly are we going to move about this solution of this particular quadratic polynomial. So for example, you have a quadratic equation 2x square minus 5x plus 3 equal to 0. So you have this particular quadratic equation with you. So now the first thing a layman would do is try guessing what exactly would be the value for x such that this equation is this still remains an equation or this condition is satisfied. So you'll start guessing. So the first number anybody starts guessing is 0. So let's start with 0 only. Okay, so you start guessing. So your guesses begin like x equal to 0. So when you put your x equal to 0, to see that if x is actually satisfied, your LHS should be equal to RHS. That is, when you put x equal to 0 in your LHS, you should get 0 because that's your RHS. So in LHS, when I put my x as 0, I have 2 times 0 minus 5 times 0 plus 3. So I have 3 which is not equal to 0, which was my RHS. So it means my x equal to 0 does not satisfy this equation, and therefore this is not a solution for this equation for sure. So next number is x equal to 1. So let's try that. So I tried x equal to 1. If I put it into my LHS, I have 2 times 1 square minus 5 times 1 plus 3. So it is basically 2 into 1 minus 5, that's minus 3 plus 3. So I have 0, which is exactly my RHS. So it means that x equal to 1 is actually satisfying my quadratic equation. So we say that 1 is a root of this particular quadratic equation. So with x equal to 1, we say that 1 is a root of this quadratic equation. Okay, so therefore x equal to 1 becomes the solution of our quadratic equation. So x equal to 1 is a solution. So remember, you call this root of your quadratic equation. So we know that a quadratic polynomial is equal to 0 becomes a quadratic equation. So it means that 1 is a 0 of your quadratic polynomial. Okay, so this also means that 1 is a 0 of your quadratic polynomial. So in general, what we can conclude is that if alpha is a real number, okay, let alpha be a real number, we have a real number alpha with us, this alpha will be said to be a root of a quadratic equation. This alpha is said to be root of quadratic equation, that is ax square plus bx plus c equal to 0. if a alpha square plus b alpha plus c is equal to 0. That is, whenever you put alpha into this our quadratic equation, if it's satisfied, we say that it is the root of our quadratic equation. Therefore, x equal to alpha becomes a solution to our quadratic equation. So this is the general that we could conclude, general form of a root of a quadratic equation that we could conclude. So from here, I told you that 1 is also a 0 of our quadratic polynomial. So from here, what we can conclude is that zeros of polynomials, that is a quadratic polynomial ax square plus bx plus c, and the roots of the quadratic equation, that is ax square plus bx plus c equal to 0, is the same only. Okay, it means zeros of polynomial ax square plus bx plus c is the same as roots of quadratic equation ax square plus bx plus c equal to 0. So you know that for a quadratic polynomial, you should have, you'll have at most two zeros. You learned this concept in your chapter polynomials. So it means that here for a quadratic polynomial, you'll have at most two zeros, right? In a similar way, you'll have at most two roots for your quadratic equation. Okay, so in our example that we have taken 2x square minus 5x plus 3, by guessing we got x equal to 1 after trying twice. So it's not necessary that we'll get a second root, because it's a quadratic equation, we should get two roots. So it means x is equal to 1 is one of the roots. So we should get another root also. So for that, we cannot keep on guessing, because guessing work is like for just laymen. But we are, studying this chapter. So we have various methods lined up for you to, understand and see how exactly our quadratic equations are solved. So one of the methods is guessing, but guessing will not always work. So then today we're gonna learn a new method. The method is named factorization. So what happens in this method is you bring out your entire quadratic equation, you reduce it to two factors, two linear factors. How exactly we do that? Let's see. So in this method, basically you do is, this is also known as splitting the method, splitting the middle term method. Okay, so basically you have this particular general quadratic equation, that is ax square plus bx plus c equal to 0. So what you try and do is you basically split your bx into two parts, and then you basically see the common in these two parts and common in these two parts, and bring out two linear factors from these. Okay, so so basically when you split your middle term, that is bx, so you have to find two other numbers, that is p and q, such that p plus q gives you b the number, and product of your PQ gives AC. So basically you have to keep these two things in your mind, that whenever you split your BX into two parts, that is PX and QX, you have to remember that the product of PQ is AC and the sum of PQ, P and Q is B. So let's see how exactly do we do that. So we'll continue with our example 2x square minus 5x plus 3 equal to 0. So in that particular example, we had 2x square minus 5x plus 3 equal to 0. So first of all, we have to find p and q such that p plus q gives you minus 5 and pq is giving you 6. So the first thing you'll blindly do is, just listen to me, trust me, the first thing you do is whatever your product of AC is, that is P into Q is equal to 6, whatever you get the product, that is 6, write down the factors of that particular number. So here you have 6, So the factors you just start writing. You have 1 into 6, 2 into 3. So this is the factors you have right in front of you. So now you have to also consider the minus, minus 1 into probably minus 6 also gives you 6. So why am I considering minus in this case? Because I have minus 5 here. So what I'll do is I'll try and check out the pairs of factors that I have if I'm getting minus 5 in any of it. So 6 minus 1 can give me 5. Minus 6 plus 1 can give me minus 5. So I'll consider minus 6 into minus 6 plus 1. But remember, your minus 6 multiplied by 1 will not give me 6. So I will not consider in such cases, pairs with the one number in which one number has minus sign. So I'll consider both the numbers having minus sign. So I have minus 1 into minus 6 and minus 2 into minus 3. So these are the four pairs that I have. So now I'll see 6 plus 1, 7, no. 3 plus 2, 5, it's not minus 5, I'll ignore it. Minus 1 plus minus 6, I have minus 7, no. Minus 2, minus 5. So now I have a pair which is giving me the number 6 when I multiply it and the sum as minus 5. Okay, so this is my pair. So now I write my minus 5x as the sum of these two. So I have minus 2x minus 3x. Okay, I can write plus here and then minus like this. I'll just rewrite it. Minus 2x plus minus 3x. So I have basically splitted my middle term into two numbers. That is, my minus 5x is now in two parts. That is minus 2x and minus 3x. So I'll simply put into my equation. So I have 2x square minus 2x plus minus 3x plus 3 equal to 0. So now my next step is I basically, as I said, I'll take common out from first two and third and fourth. The pairs are like 1, 2 and 3, 4. So when I take common out from these, I have 2x, x minus 1, and from these two when I take common out, I have minus 3 and then x minus 1. So I'll write minus 3 x minus 1. Why? Because I have taken out minus 3, so I have x minus 1. So now in this step, you'll have to remember that whatever you take out your common, both the pairs, that is 1 and 2 and 3 and 4, just make sure that this part, whatever is left inside the bracket after taking out common, is the same. Why do you need it as the same? Because again, from this step, you'll take this particular part out as common. So you have x minus 1, whatever remains, 2x minus 3 equal to 0. So this is how you split your entire quadratic equation into two linear factors. So now from here you know how to solve it. Either this particular part is 0 or this particular part is 0. So basically you have x equal to 1 and x equal to 3 by 2. So as x equal to 1, we solved it as, as a part of our guessing work. So x equal to 3 by 2. See, this is not something you can easily guess, okay? You cannot, start going about 0, 0.1, 0.2 and go on up to 1.5. No. So that's why we need such methods to actually simplify our task. So the first method we did is factorization or splitting the middle term. So basically in what we do is we basically list our factors of our AC, product AC. We see which pair actually gives you as a sum as B, and then we use it in our equation. We take common out from the first two and third, fourth. We make sure that whatever is left in the bracket is same. Then we take these two terms out as common. Then whatever is left, that is this part and this part. So we write down both of that together and then we equate them to 0, the linear factors. We get our solution or the roots to our quadratic equation. So this is our first example. Okay, so let's do a few more examples. So in the next example, this is example number 4 of your book. Okay, it says the question is x minus 1 upon 3x equal to 1 by 6. So this is not exactly in our general form. So first we'll convert it into general form so that it becomes easier for us to factorize and get the answer for our x, the roots of a quadratic equation. So when I simplify it, I have 3x square minus 1 upon 3x equal to 1 by 6. If I simplify it further, I have 6x square minus x minus 2 equal to 0. So this is your quadratic equation. So now we have to look for p and q such that your sum p plus q gives you minus 1 and pq gives you minus 12. So now you list out the factors for minus 12. So what are your factors for minus 12? It's minus 1 into 12, 1 into minus 12, then you have the pair 3 and 4. So you basically write 3 into 4 or else 3 into minus 4. Then you have your pair 2 and 6. So you'll write minus 2 into 6 or else 2 into minus 6. So these are the factors of minus 12. Now you'll start checking the sum of each pair if which one has minus 1. So we can simply eliminate these two. These are definitely not going to give me minus 1. If I have a look at here also, this is also not going to give me minus 1. The only possible pair are this. So I need minus 1. So my minus sign should be with 4 so that I have minus 4 plus 3 which gives me minus 1. So this means this is also not possible. So this is the pair which satisfies both the conditions. So I'll simply split my middle term minus 1x into minus 4x plus 3x. So if I put that into the equation, minus 1x can be written as minus 4x plus 3x. So if I put this particular thing into my equation, I have 6x square minus 4x plus 3x minus 2 equal to 0. So now my 1, 2 and 3, 4, I'll start taking common out from these. So if I do that, I have from the 1 and 2 part, I have 2x as common. Okay, so if I take 2x out, I'll be left with 3x minus 2. So again, you can see in this part 3x minus 2, you have nothing to take common out, and you can see that whatever after taking common out from the 1 and 2 part, I have 3x minus 2 only. So you have nothing to take common out, you simply write plus 1 and then write 3x minus 2 equal to 0. So now basically, as I told you, you have this part as the same for both the sides of 1 and 2 and 3 and 4. So basically you now take this 3x minus 2 out as common. So you have 3x minus 2 out as common. Whatever is left, that is 2x and plus 1. So you will write 2x plus 1 equal to 0. So you have now two linear factors for your quadratic equation, 6x square minus x minus 2 equal to 0. So whenever you equate it to 0, it's either x equal to 2 by 3 or x equal to minus 1 by 2. So you have the two roots for your quadratic equation, x equal to 2 by 3 and minus 1 by 2. So this was our first method that we can use to solve our quadratic equations. So what now you can do is you can go back, have a look at whatever quadratic equations that we had constructed in our last class, the plot question, the Rohan's question, the metal square sheet that we discussed starting in the beginning. So you can try solving them using the middle term, the splitting the middle term method, the factorization method.
And so we come to an end to today's lecture. Thanks a lot for watching this, and stay tuned for the upcoming ones. Don't forget to follow @fastesthumancalculator and @exp.infi on Instagram, and subscribe to our YouTube channel.